Okay, class, good evening. So just give another 2 or 3 minutes of your friends to join. I think still 18 of you. Okay, students, can you hear me? Anyone can respond?
Yes, can hear.
Okay, okay.
Yes.
Okay. So just today is about how to answer the paper 4. So paper 4. So I think we can start now. We can start now. Okay, so it's going to be like 1.5 hours, but I tried to. If I finish early, then I stop. Okay. Okay, so physics workshop paper 4 is about your, of course, these are the exam papers you're going to see. Okay. So paper 4 carries most of the mark. It's 38.5%. Okay. For the entire A levels. Okay. So if you're paper 4, you overall you get A means I think overall should be A or one grade lower. It won't fall beyond that. So paper 4 is a determiner, no doubt about that, for your entire A-level examination. Okay. Okay, so as you realize, there are 16 topics. Okay, there are 16 topics in your A2. So circular motion, gravitation, up to telecommunication. Okay. So I think now you most probably like almost going to finish the topic. I think maybe some of you finished it. Okay. So out of these 16 topics, let's we see the breakthrough. How many times the question has been asked? Okay, for the past 5 years, we did an analysis. So this is the analysis revealed. So this is the analysis from 2015 to 2019. Okay, June and winter paper. Okay, so you see this analysis. This is up to topic 9. So out of this analysis, you can see that which topics are frequently asked. Of course, there are about 16 topics, but for paper 4, I think average you'll get around 12 structured questions. Out of 12 structured questions, yeah. So out of 16 topics, you only get around 12 structured questions. Some topics might not be asked, but the one frequently asked, according to the list, you can see like gravitation. Gravitation, every year there'll be one question. Okay, so far the track record shows every year it will register one question. Circular motion looks like 50-50. Okay, if it comes up, it will be together with gravitation, most probably. And temperature looks only once in 5 years' time. And so, yeah, temperature about thermometers. And ideal case also registered registered every year at least one question. Thermal most of the time, 1 year didn't appear. Oscillation also clean sweep every year there is one. 1 year only half came out. Electric field also clean, every year there is one. Capacitance is like circular motion, not much of just 50-50 chances to come out. And magnetic field, this is the top in entire topic if I have said. Because why I say that, because not only registered every year, there is some years like more than one question appeared for magnetic field. So yeah, so give importance for the magnetic field because it gives lots of marks. Okay, then another 16 topics, electromagnetic induction. So induction, I can say quite fair. It came out for the exam. Only twice doesn't appear. Okay, and alternating current is exactly same as electromagnetic induction. I think a little, yeah, two or three times never appeared. Quantum can say quite one of the important topic, because sometimes there is only 1 year never turn up, but other years sometimes got two questions. One from CT scan, from medical, one question will come up. So it's about two questions sometimes registered by quantum physics. And nuclear also every year there is one question. Direct sensing, your like op-amp, there will be 7 or 8 marks waiting for you every year, every paper without fail. And wave is your ultrasound, ultrasound moderate, and telecommunication. Okay. Telecommunication also I can say the another important topic. One year didn't turn up, but most of the time there will be one. Okay. So overall, this is the number of questions came up in 5 years period. The one registered more than 10, I think that's the famous topic normally will be asked in exam. So gravitation, ideal gas, electric field, oscillation also I consider as one common one. Magnetic field, and quantum came up 13 times. I think is the leader of this all the topics. Nuclear 10, and direct sensing, and telecommunication finally. Okay, so giving most of the questions are coming up from these topics. Okay, so topic frequently tested. Okay, so far any questions? No questions, Okay, can you hear me, right? Okay, I do one suddenly disconnected. Okay, so that's about frequently tested topics. Okay, next is the glossary of commands. What are the common words will be used in examination? I believe you went for AS last semester. I think maybe when you are before you sit for AS, you went for A2 briefing. There they give a list of command, but here we're going to discuss only the main command which frequently come out. They are about 16 commands if I'm not mistaken, but only the 4 commands really dominant, frequently asked. The first command normally they ask is define. Okay, so whenever the way say define electric field, define capacitance, define photon. Okay, so whenever they say the word define, so intended literally, you just need to give a formal statement, or you just state the equation. Okay, you just mention the equation. Okay, like for example, like photon. What is photon? It's a EM radiation. It's a packet of energy of an EM radiation. Okay, E equals to HF. Okay, kind of like a formula. You explain the formula, also accepted. Okay, so define with symbols and identify is required. Okay, like yeah. So electric field strength, you said of the ratio of force to the positive test charge, and you mentioned E equals to F over Q. You mentioned what is F, what is Q represents. That defined. Okay, no need extra details required. Okay? So, for example, define electric potential at a point. So 2 mark. So what are you going to answer? Electric potential. So recall. So is the work done per unit positive charge to bring the charge from infinity to the point in the field. Just what do you call paraphrase explaining the definition. Okay, next, the one a bit what do you call demanding is what is meant by. Next the command word is the what is meant by. Okay, what is meant by electric field? Define electric field. Electric field strength. Sorry, define electric field strength. So force per unit, positive test charge. What is meant by electric field? This carries more mark. Okay, whenever they say what is meant by electric field, it's just not enough to define it, but you need to tell extra information about it. You can tell it's a vector quantity and so on. What is meant by? Normally implies that the definition should be given. You must give the definition. together with some relevant comment, some feature about that term, significant of context of the terms, especially where two or more terms are included in the question. Is it parallel? Is it the two quantities need to be parallel, and so on? You have to describe. So conclusion is, for example, the same question I repeated here. What is meant by electric potential? Earlier was define electric potential. They asked what is meant by electric potential at a point. So definition alone is not enough. So what you say? You must tell definition plus with a supporting statement. You must give a supporting statement, some feature about that quantity. So in this case, you can tell, yeah, work done per unit positive charge to bring a charge from infinity to the point in the field. Then you need to give us some supporting statement. For example, it is a scalar quantity. Okay, it's a scalar quantity, and so on. So supporting factor is required whenever they say what is meant by. Okay, very quite frequently they use these common terms. Any questions so far? Okay, let me continue. If anything, just you can talk to me. Okay, so up to next, what is meant by? Third, describe. Okay, so describe why the charged particle moving like that. So describe candidates should give an account of what will happen. Reason is not required. Okay, describe means what is the consequence movement or consequence effect to the system. Reason not required. You don't need to tell the reason. Okay. For example, let's say describe the path of electron moving perpendicular in a magnetic field. Describe the path experienced by the electron in a perpendicular and magnetic field. So because they say describe, you just tell what path it takes. You don't need to give reasons why it makes that path. Okay. So yes, it makes an arc of a circle. Okay. So arc of a circle, that's the answer. So you just describe what pattern you're going to take, but you don't need to give reason for it. Why it make an arc of a circle. So you need to tell. They say describe. So describe, I think, not that demanding. Just describe what is happening. That's it. Okay. But if the fourth term, they ask you say explain. So explain is little demanding compared to describe. Okay. So question comes out explain, imply reasoning. You must some reference to the theory. Explain. Okay. For example, there is one year they asked a string is oscillating up and down in the middle of a magnetic field. So they're asking explain why the EMF generated is alternating. Okay, so you need to give a reasoning with referring to the law. Okay, the law. You say it's alternating because the direction of the cutting of the magnetic field line is changing. Not enough. You must tell based on Lenz's law. So you must refer to the theory also if there is one. Okay. So for example, here we give another one. Explain path of electron moving perpendicular in a magnetic field. The same question earlier was describe the path of the electron, arc of a circle. Now the question is explain the path of electron moving in a perpendicular in a magnetic field. So 3 marks. So what are you going to say? You must say what pattern you're going to move, arc of a circle, but you must give reason why it should move in that manner. The reasoning you must tell. So for suggested answer is like this. Arc of a circle, 1 mark, because the magnetic force is acting normally to the direction of the travel. And of course, the third point, this force provides the centripetal force for the electron. So you can't stop at arc of a circle. Okay. So another one, gentle reminder, whenever you answer any questions, I think many of you following this, I believe, you check the marks. If 3 marks, you must give 3 points, of course, right? Yeah. So these are the main 4 command words normally comes out in your exam. Okay. So any questions so far? No questions, huh? Okay, so let's continue. Okay, students can hear me, right? Anyone?
Yeah, can.
Can, eh? Okay, good, thanks. Okay, next. Yeah, so this is another one. Sometimes they ask for question, sometimes they ask for reasoning. Like for example, 2 reasons or 2 features. 2 features about electric field. Okay, and 2 reasons. So or 3 reasons. They give n number of responses. Okay, so if they ask for 2 reasons, can you write three reasons or not? One extra. What will happen if you write 3 reasons? Do they going to award mark or they going to ignore it? Okay, that's what we're going to discuss here. Is it good to write more than 2 reasons, more than requirement? Okay, so according to Cambridge, this is what the detail they give. The first table is, you see this table, okay? So this table explains the question requiring for 3 reasons, 3 reasons, okay, 3 reasons, okay. Let's say the first reason, he wrote 3 reasons. This the first student A, candidate A wrote 3 reasons. So first correct, second correct, third wrong. So he got a 2 mark. No problem. Okay, no problem. 2 marks. Okay, B student is a little hardworking. He wrote 4. Okay, he wrote 4. So the first 3 is found to be correct, and the fourth one is found to be wrong. Okay, the fourth one found to be wrong. So the Cambridge said, okay, ignore the fourth point. So full mark will be awarded. Okay, so the extra he wrote is wrong, so it will be ignored. Okay, so it's fine to write the fourth one, but you see the candidate C. Okay, this is sad. Candidate C. You see here, candidate C. It's very important candidate, I think, for you. This guy also wrote 4 responses. Okay, he wrote the first 2 is correct. The third one is found to be wrong, and the fourth one is correct. Okay, the fourth one is correct. So what happened? You see, the Cambridge ignore the fourth one. They ignore the fourth one. So the mark awarded only 2. Okay, this is a pity actually. Sad. So what do you learn from the response for the C? So if they ask for 3 responses, in this case, the question, they ask for 3 responses, 3 reasons, and you wrote 4, okay, better you write the most important 3 one, you feel dominant one, you feel that's going to be the correct answer first, okay? The fourth one, which you feel not that, you are not sure about that fourth reason, and you really want to write it, put it as the fourth. So you must be good in categorizing which is most dominant one, which is you feel correct for sure, and which is not, you are like intermediate, you feel this might not be a correct response, then put it as the last one. Okay, so that's the what do you call outcome we can conclude from this response C. Okay, look at D. Okay, D also wrote 4 responses. First correct, second was correct, but unfortunately, third was contradict with the second one. The third one is contradict with the second one. For example, the question is asking, okay, write the 3 features of electric field. So first you wrote the force acting due to electric field. The force due to electric field is act on charged particle. Okay, 1 mark. Okay. Second, the student wrote the force due to electric field is parallel to the field line. Okay, good. You got the next mark. But third point, he wrote the acceleration of the charged particle in the electric field is perpendicular to the electric field line. Oh, this is contradict with the second one. Second one, the force is parallel to the field line. The third one, you say acceleration is perpendicular to the field line. So what the Cambridge will do, they won't award the second mark, okay, because it's contradict. So the what do you call it? The candidate going to lose the second mark. Okay. But this candidate, thank God, he wrote the fourth one, but the fourth one found to be correct. So you get 1 mark for the fourth one. Okay, so you get a 2 mark together. For the D respondent, I think he lucky he wrote the fourth one because the second and third was contradict. Okay, so please make sure when you write the responses or the reasoning, make sure they are not contradict. If contradict, you're going to lose mark. The correct one also going to lose mark. Okay, give importance for the D. And E, you see the E is the correspondent E, he wrote 4 also. Correct, second correct, third one is correct, but fourth one is wrong completely. Okay, so ignore. The fourth one is ignored. Okay, the fourth one will be ignored. Okay, we have more. So F, you can see the E wrote 4 again. The first 2 correct. The third one is correct, but the fourth one is contradicting the first one, third one. So the third point is missing. So you only got 2 points. Okay. And the G, he wrote 5 responses. He wrote 5 responses. First 3 is correct. The fourth one also correct, but will be ignored because he already got a foot mark. But the fifth one is contradict with the fourth one. Lucky, because fourth one, so he ignored. So you get the complete mark. Okay, 5 responses. Okay, this is how it goes. H, correct, contradict with the second one, you lose the second mark. Okay, the third one is correct, then you will get a mark. So it's 2 marks. Okay, and the last, correct, and finally is contradict with the second one, so you won't get mark for the second one. Okay, so students, what is the conclusion here? If they ask for 3 reasons, you want to write 4, you write 1 extra is fine, but try to categorize it. The most you are confident with, write the first. The least confident, write the last, and make sure nothing contradict. Okay, contradict, you lose mark. Okay, so this is about the end responses. End responses. Okay, any questions so far from here? Okay, so hope you get the idea. Okay, so we go to the next slide. Okay, next is mark categories. Okay, when you look at your mark scheme, you're going to see some category marks: B mark, M marks, and what C and A marks. Okay, maybe your teachers have, your lecturers have explained this before. Last time, paper 2, you learned this also, right? Okay, so B mark is an independent mark. Is independent, not affected by other points. Okay, so you get a B mark. B mark is independent. Easy to get B mark as long as you have the independent mark. M mark is the most dangerous one. Method mark. Okay, method mark. If you didn't get method mark, then you won't get the answer mark. You won't get the answer mark. So method mark is very important. Okay, so if method mark is correct, you get 1. The answer mark wrong, you lose 1 mark. The answer mark you won't get. Okay, but if answer is correct but method is wrong, you won't get any mark. Okay, so that's method mark. Okay, yeah. For example, they ask, what is the path experienced by a charged particle in magnetic field with the reason? So you say it's going to be a circular path. Okay, it's going to be a circular path because the force is perpendicular to the direction of motion. Okay, the force perpendicular to the direction of motion may be a method mark, M mark. And the second, you say circular path. So you say circular path, but you never mention force is perpendicular to the direction of motion. And that mark is a method mark, so you won't get any. So method mark, be careful. Okay, third is a C mark. It's a compensatory mark. Compensatory mark, you know, it's like compensate your compensation, like compensate if your answer is wrong. Yeah, for example, let's say you have a calculation. When you have a calculation, the first you have to do is you write the formula, maybe FC equals to FG. Okay, it could be a C1 mark. Okay, and the two, so MV squared over R equals to GMM over R squared, and you do the substitution. You do the substitution. You put the number, the mass, maybe 5,000 kilograms. So you put all the numbers substitution, and that will be a C1 mark. And final answer could be final answer is A1 mark. Okay. So if a student never show the FC, he never show, never give a statement. Sorry. A student never give a statement and never write MV squared over R equals to GMM R squared. But he finally just show this substitution. He just show this substitution and he got the answer. And the answer is correct. Okay, the answer is correct. So he got the answer mark 1. Because C1, the substitution he show, he got 1 mark. Because he never show the FC and FG, he still will get the mark. He will still get the mark because the answer is correct. The answer is correct. So Cambridge found that he eventually should know that this information in his head, so should be awarded that mark. It's compensatory mark. Compensatory mark. But it's not advisable lah. You don't forget to write the equation. But sometimes if you are unlucky, if the answer is wrong, A1 is wrong, then you never write the equation FC equals to FG. You just show the substitution, then you only got 1 mark. So they won't give this mark. So the best practice when you write answers is first you do what? Write the what do you call the what equals to what? What equals to what? The centripetal is equals to the gravitational force. In the statement, give a statement first. Write the statement. Okay, statement first. What equals to what? Then write the equation. Okay, write the equation. Third, write the substitution. Okay, substitute all the information. Fourth, the final answer. The final answer, please write in 3 significant figure or 2, check the least significant rule. And don't forget the unit. This is the best practice lah when you write your answers. Okay, always follow this step. Okay, so you will get the compensatory mark, although your answer is wrong. Okay, so that's the C mark. Okay, yeah. So finally, it's a A mark, of course, answer mark. Answer mark. Your final answer is correct, then you get the A mark. Okay. So, any questions? So no questions, Okay, so far you learn about the topic and we learn about the, what do you call, the common words, and we talk about the, how many reasons you write, and now the mark categories. Okay, now let's try one question, and we see how the candidate answers with the question. Okay, so I show you a question. Okay, so this is one question. It's a June 16 question 42, question 1. Okay, might look quite small. Hope you can read it. Okay, students, what I want you to do, okay, read the question. I give you 1 minute. Read the question. In your mind, try to have the answers. Try to imagine your answers, or you can write down your answers. No need to do a complete working. Just what are the points you're going to write out? Write it first. Okay. So we go to the first page. Okay, 1 minute for you. 1 minute. Take 1 minute. Read the question. Write your answers roughly. So it's about gravity. Okay, so try to predict the answers first. What are you going to write? Okay, so you have an idea in your mind. What are you going to write? Are you going to write the formula? What formula you must going to write? What are the substitution you're going to do? Do you have any conversion you think you should be done, that you should do? Just visualize it first. Okay, so yeah. So it's a gravitation topic which is every year comes out. Okay, so a binary star consists of two stars A and B. They orbit one another as illustrated. So star A, star B, there is a common point P. The star in circular orbit with the centers of both orbits at point P, a distance d from the star A and star A, star A, okay. So explain why the centripetal force acting on both stars has the same magnitude. Okay, why the centripetal force for both stars must be the same magnitude? It's 2 marks. So when you read the question, check it's 2 marks. So you must tell 2 points. Okay, explain. Explain means you not only must you put the fact, then after that you need to explain it why it's like that. Okay. So I hope you have your answer in your mind for 2 marks. Okay. Okay, next. The period of the orbit of the stars is about 4 years. Okay, the period is 4 years. Calculate the angular speed omega of the stars. So what formula to be used? How are you going to get these 2 marks? So you're going to write the formula, you're going to show the substitution, and the final answer in 3 significant figure. That's the best practice. Okay, I hope you have a rough idea your answers. Okay. Okay, I go to the next slide for the continuation. I don't want you to have a complete answer. Just try to imagine what you're going to write. Do you going to write a formula? Okay, write out a formula. Do you going to tell the substitution or you put the substitution? Okay, substitution. What are the substitution? Is there any conversion? Do you convert it properly? Check that. Okay. Okay, so let me go to the next slide. Continuation of this question. Okay, next slide. Okay, B. The separation of the center of the star is this much. The mass of the star A is MA. The mass of the star B is MB. The ratio of MA and MB is 3. Determine the distance D. 3 marks. So these all are calculations now. So yeah, how do you find the distance D? What is the distance D? What is the distance D? I go back to the question. This is the distance D. Distance D is the distance between A and P. Distance D. Okay, so in your mind, please think what formula to be used, what type of substitution you're going to make, and what do you think the final answer should be. Okay. And to use your answer in A2 and B1 to determine the mass of B, of stars B. Explain your working. Okay. To explain why it's like that. Okay. You must give a statement. Okay, so 3 marks, 3 points. 3 points, 3 points must be there. Okay. Okay, students. Okay, so let's see some answer script by students. Okay, from Cambridge actually. So So how the marks has been awarded, how he answered, how many marks it has been awarded. Okay, you have your own answers with you. You can compare. Okay, you can compare. You can check how many marks you get. Okay, first, a candidate with high response, a good candidate, how he answered the question. Okay, first question. Okay, this is how he answered the good student. Explain why the centripetal force acting on the both stars are the same magnitude. Okay, why same magnitude? Because both as the because the centripetal force acting on both stars are provided by the gravitational force. That's one mark. The centripetal force in this system is provided by what type of force? Gravitational force. That's one mark. Okay, so this student clearly explained that the centripetal force is provided by the gravitational force. Okay, then he wrote that GMM or R squared equals to MR omega squared. He didn't mark for that. The angular velocity omega and the period t is both stars are the same. The angular velocity omega and the period are the same. So the centripetal force and gravitational force for both stars are the same. Yes. Keyword is, you must say the centripetal force is provided by the gravitational force, and the gravitational force for both is the same. That's the two keyword they must tell. Hope these two in your mind. Centripetal force is the gravitational force, and the gravitational force for both body is same. You get 2 marks. Okay, so the number one, the candidate clearly states what provides the centripetal force in this system. So 2 marks is awarded. Okay, 2 marks is awarded. It's a full score by this student. Okay, you know what this question wants. The gravitational force is the centripetal force. The gravitational force for both body is same. The 2 marks. Okay. Okay, next is a calculation question. The calculation question, they're asking for what is the period of the stars for 4 years. Period of the star is 4 years. Calculate the angular speed. So the formula must come to your mind is omega is 2 pi over t. Yes, omega is 2 pi over t. So he wrote the equation correctly, but it's only 2 mark. The answer must be, the substitution might get 1 mark, and the final answer is 1 mark. So this student's quite good. He show the equation, he show the substitution, and the final answer, he never go for big number of significant figures. Here, the values given are 2 significant figures. Actually, he must go 2 SF, but 1 extra is okay, fine. This 3 SF is still accepted. So here also 2 marks, he got a clean sweep, he got all the marks. So number 2, an equation is provided linking to the 2 forces. Yeah, equation is given. Explain why the 2 forces are the same. So this is the second one, the third one, sorry. A correct calculation is performed with the candidate clearly showing how the period is converted from years to seconds. Yeah, the conversion they are focused to. The 4 years have to place in seconds. He converted 365 times 24 times 360, 3,600. So he got awarded all the marks. Substitution, final answer. I believe all of you, most of you will get the 2 mark, 2 and 1. 1 you must explain, so you get 2 marks, 2 questions, 2 marks. So this is a high response student, so you get all the marks. Okay. The next part, still high candidate. So next, B1, you see the B1. So determine the separation of the centers of the star 2.8 times 10 power 3 kilometer mass of A is MA and MB. MA or MB is 3. Determine the distance, okay, D. So the student clearly start with the centripetal force must be same for both of them. And he clearly put one is D, another one is 2.8 times 10 to the power of 8 D. Okay. Okay, so correct statement is the centripetal force is same. So the candidate uses the fact that the centripetal force on the 2 stars is the same. The statement given mark, 1 mark. And the common mistake student like to do is the D. 1 D, another one is the total distance minus D. The substitution was correct and equals to 3. And the final answer, you never go for a lot of significant figure. He wrote 2. So he got full mark. Okay, 3. So m over r omega squared for both must be the same. Earlier, I asked you to think about the answer. Maybe one must be in your mind is d, another one is the total distance minus d must be in your mind. And this is the working one. So you got the full mark. And yeah, finally, use your answer in A2 and B1 to determine the mass of B of the star B. Explain your working. Okay, you already know the D. Okay, you already know the D. So you can use MA or MB is 3. So you can use GMM over R squared equals to MR omega squared. Yes, correct formula. GMM over R squared equals to MR omega squared. This is 1 mark. Then correct substitution, MA equals to 3MB. Correct substitution. But here, what happened? I think finally, some algebraic, some error in the calculation. What is messed up? The T times MB 2.8 times 10 to the power of 8 times 10 to the power of 3. Okay, a correct starting equation. You got a 1 mark. Correct distance value in meter inserted. However, the candidate has made an arithmetic error towards the end. So answer is supposed to be 2.04, but he got 2.72. So what happened? He lose the answer mark. So he scored only 2/3. So this entire question is scored 9/10. Okay, 9/10. This is the high responsive, high response student who good student. Okay. Okay. So we have another candidate with the middle mediocre. You need to categorize yourself where you are. Okay. You know your answer in your mind just now. Check which group are you in now. So the middle responses, the first answer he wrote, explain why the centripetal force acting on the both magnitude. Yeah, both have same angular speed. Angular speed for both of them is same. Okay, but that doesn't tell that the centripetal force is same. They act as a point mass. Okay, the gravitational Coulomb, what do you call Newton's law points, not related. Mass as negligible effect of forces. So it doesn't explain about why they same. There is no reference to gravity. There is no reference to gravity. So you didn't get any mark, although you write a lot. No mark. Okay, next. Part 2, omega is 2 pi over t is substituted correctly. Okay, this is fine. He did a very good job. Equation, substitution, final answer, 3 significant figure. Okay, so you got a 2 mark. Okay. So, yeah. Okay, next, yeah. Okay, so MA equals to MB, same. So you said, okay, the centripetal force is the same. So correct formula. And one D, another one is the total distance minus the D, did correctly. And you got the final answer correct. So you got a full mark. Full mark. Okay, I used to come across lots of scripts without writing the first line. Without writing the first line. Never show the equation. Never throw with it, or never give the statement FC equals to for both is the same. Try to practice writing the first line. So you got a full mark. And the last one, use your answer in B2, A2 and B1, determine the MB of the star B. Okay. So here what he did MR omega squared equals GMM over R squared. Okay, good. But here I think the mass of A, mass of B is missing. Okay, mass of B is missing. So he didn't get any mark. He didn't get any mark. Okay, and the substitute of the mass is not clearly stated. The candidate makes a common error here using the same distance for both. Yeah, the distance is the same. Both R and R squared. Okay. Yeah, the distance was the same. MA or MB has been substituted by 3. So same distance for both radius and the orbit. Okay. Yes, this r should be the d. This r should be the entire distance phi. So he thought r and r squared is the same. So he made a mistake. This candidate also incorrectly cancels the distance. So yeah, the r cancels. Of course, if you consider same, you're going to cancel it. So it didn't get any mark from here. So this this candidate only got 5 out of 10. The main mistake he done, I think the final part lost him 3, and the first part, explaining part, he made a mistake. Okay, so this is middle. And so how the candidate could have improved the answers. Okay, so first, yeah, they should tell some reference to the gravitational force was required. The candidate needed to insert a correct distance, the distance of 2 stars for gravitational force. Yeah, and basic mathematical requirements simplify the equation. Need to improve on that. These 2 candidates. Okay. So far, any questions? Okay, this the high and the medium. Okay, and the third one is low response. Okay, this is not a good script. So first, explain why the force is same. The force of both stars are couple. Okay, it's a couple. The torque equal to the centripetal force. You can't use torque. Torque is of course it's a turning effect. But why the force same is the gravitational force same. So the point entirely wrong. You talk about torque. There is no reference to gravity again. You see, they are very consistent. They want you refer to gravity in this answer. And the force involves are not torque force. It's not torque. It's not about torque. Okay, so you lose entire mark here. Okay, the second part, as usual, clean sweep. You got all the 2 correct equation, substitution, and the final answer. And here, I think the force same, Fa equals to Fb, gravitational force same, GMM or R squared, GMM or R squared. I don't know why MA and MB is there. MA, MB, both sides will be cancelled, right? Mass will be cancelled. R will be different, but he put the same R. It's totally wrong. It's totally wrong. No mark awarded for this section as the candidate are not made use of the fact that the centripetal force on the 2 stars are the same. Okay, so the keyword here, centripetal force of the star A equals to centripetal force of the star B, need to be stated. So we didn't get any mark here. So therefore, this student is a chain reaction. So he's stuck here, then here also difficult to get a mark. The candidate insert F for the force on the star B as not related. This equation for the centripetal force just uses a mass m, and the correct MB needs to be linked to the correct radius. Okay, so 0. So this candidate only got 2. Okay, so this is I don't know which. Try to visualize. Which category are you in currently. So are you always doing the best practice, that writing the statement and writing the substitution and the final answer with a 2 significant figure always. Okay, and the part A, difficult to tell. You must have the gravitation knowledge well to explain it. Anything coming to centripetal force, you must tell what force acts as a centripetal force always. Okay. Okay, so another one try. Okay, so this candidate, sorry, the last one. The one who scored quite badly. The candidate require a better understanding of Newton's law. He not really understand well the Newton's law. He go for torque. It's application of rotating stars. There was no reference to gravitational force. A candidate realized that the centripetal force on the 2 stars are the same. They not really required. They never realized that, the student. The candidate needed to use their answers in A2 and B1 as stated in question. Okay, class, another clue. I always tell to students, if you don't understand the part C, the clue is on top. You have to make use of the answer. Cambridge always guide the question. They are related one after another. So part C, you don't have the idea. The idea is on top, part B and part A. Okay. Okay. So yeah. So these are the common mistakes. Common mistake candidates in these questions are many candidates did not link the force on the rotating system of the stars. Yeah, gravity. A common error is the 360 days has been not changed to seconds. Conversion. This is another main problem. I think only in physics subjects, all the numbers given will be awkward. Okay. Okay, students, sorry, I think disconnected. Okay. Let me go back to the slide. Okay, students, can you hear me again? Sorry. Can Hi, everyone.
Can.
Okay. Right, class. So after these questions, after this reasoning, let's try another one. Okay, another one. Okay. So this is another question. This is simple harmonic motion. Another important topic. Okay, another important topic here. So there is a spring hanging. There is a block at the bottom. Displacement graph was obtained. It's a negative cost graph. Okay, and they said the vibrator is switched off. The metal block is under 20 gram. Displaced vertically and then release. The variation with time t of the displacement y of the block equilibrium position is shown. Okay, for the vibration of the block, calculate the angular frequency omega. Okay, again, try to visualize it. What you're going to write here? It's a 2 mark. Okay. So what formula? What is the substitution? Any conversion required? Think about it. Okay. Always tell, is there any conversion or not? Okay. So what formula you use in this formula? The angular velocity. Angular velocity. So read the question. So what formula do you think is omega equals to? I think 2 pi over t must come to your mind. Omega equals to 2 pi over t. And the period, of course, you must know that you can get it from the graph, 0.6. Okay. Then 0.6, check the units. Okay. Another mistake, check the units. This is centimeter, this is in second. So no need any conversion. So you can get the omega. Okay. Okay, next. The energy of the vibrations. What formula comes to your mind? How are you going to go about with this answer? So half m omega squared x naught squared. Okay, must come to your mind, the energy of the vibration. And substitution, any conversion required? Think about it. Okay, so yeah. So what conversion you must do? the mass is given in gram, so you have to convert to kilogram. And the omega, just now you got it, fine. And half m omega squared x naught squared. The amplitude is in centimeter, you have to convert it to meter. So lots of two conversions. Mass is kilogram, amplitude is in meter. So hope you can visualize what you're going to write. Yeah, okay. The final answer is 2 or 3 SF. Okay. Okay, look at B and C. Okay, B and C, 1 minute. Try to sketch the graph by your own first. And let's see, you can get 5 marks. 5 marks for the graph. For the block, complete 4.3 to show the variation with frequency of the amplitude of the vibration. 3 mark. Some light feathers are now attached to the block B to increase air resistance. The frequency of vibration is once again 0.7 F to 1.3 F. Draw a line to show the variation with frequency. Okay, class, this is lots of marks, 5 marks. Okay, let's see. You try to sketch one, and let's see, can you get the 5 marks or not? Okay, just 1 minute for you. Okay, so you're done with the graph, the 2 graphs. Let's see if you can get 5 marks or not. So amplitude versus frequency. Recall back your SHM. How this graph looks like. 5 marks a lot. 5 marks a lot. You need to draw 2 graphs. One without air resistance, 3 marks. One with air resistance, 2 marks. Okay, so I hope on your table you have the sketch for the 2 graphs. Okay, so let's see now the answers. Okay, the candidate with high response. So yeah, so you write 2 pi over t, good, and it's correct substitution. And the final answer is 10.47. He wrote 4 significant figure. It's not that good, but look, finally he trimmed it to 3. Okay, good. So he knows that it used not more than 3 SF. Okay. Sometimes the student will give the answer in terms of pi, not advisable. Put it in decimal form. The pi just substitute 3.14, then you get the decimal form. So the candidate starts with the correct equation and correctly reads the period from graph. Okay, you read 0.6 and correct substitution, you got 2 marks. Okay, so no problem, easy. Okay, the next one. So the energy of the vibration, okay, half m omega x naught squared. This energy, what the energy you want? The energy, kinetic energy or total energy? The energy of the vibration. Sorry, this is the middle one. Okay, so energy of the vibration half m omega squared x naught squared. This is the answer. This is the equation. The equation, I think for this equation no mark, but the substitution given one compensatory mark C, and final answer. You give 4 SF, but finally you put 2 SF. Good. So be careful, write 2 SF. And yeah, Joule. Okay, another one student I like to highlight here. I see many times some students they tend to, sorry. Okay, they will get the answer in let's say joule, but here let's say they give kilojoule. Let's say they got kilojoule the answer. Here the answer is given joule. They tend to put at K. They change the unit. Don't do that. Okay. The Cambridge one joule, that's their instruction. Don't change the instruction. Okay. So if they want joule at the side, you give joule. Don't change the unit. Okay. Okay, next. Hope Okay, this is the graph drawn by this candidate. So you see the graph, of course, it's a resonance graph, right? It's a resonance graph. You've seen that while your lecturers taught you in class. So when the natural frequency at f, of course, the amplitude will get larger and go down. So the curve is nice, like a smooth curve going up and come down. The peak achieved at the natural frequency, good. You got 3 marks. Sorry, you got 2 marks. 1 mark is wrong. 1 mark he didn't get. Why he didn't get 1 mark? Because you see the statement, he never finished drawing up to 0.7 to 0.3. There's just a small gap left. The candidate has drawn a clear line which has a correct shape and peak f. 1 mark is not awarded because the line does not start at 0.7 f, nor finish at 1.3 f. Okay. This is cruel. They are very particular about here. He never finished here and here. Okay, halfway he stopped, so you lose 1 mark. So PT. Okay. Okay, so next, it uses the, what do you call, the feathers. So what happened? Friction happened. So it's damping happened. So of course the graph going to be lower than the without resistance, going to be more damped, heavy damp. So the curve going to be the same curve, but the height going to be lower than the original one. So yeah, he managed to give a lower one, good. But the biggest problem he got, this is 2 mark, he got a 2 mark, yeah. The candidate has drawn a second line, label B, which is correctly below A along all its length with the maximum at F. Okay. So second curve should be below the first curve. So this student, out of 5, he lose 1 mark because he never finished the graph. Class, be careful. If they ask to draw 0.7 to 1.5, completely draw the graph. Follow the instruction. Okay. Sometimes for an oscillation graph, they ask you to do light damping. You draw one, you draw another one, you stop. But Mark Spin, they will put at least three lines, three waves. So those who are drawing only one up and down stop, you might lose mark. So my advice is, you see the scale. The scale is given like you can fit in 4 oscillation. Go ahead, draw 4. Just draw 4. Just make sure fill up the entire graph. Don't miss out the easy mark. Okay. So yeah, this student was a little careless towards the end, like he never joined it, so he lose 1 mark. Okay, so out of 9, he awarded 8. It's a good response. Good response. You lose 1 mark, I think it's a silly, what do you call it? It's a careless. Okay. Okay, the middle one. This is a middle responding. So he got a 2 mark. So omega equals to 2 pi f. He found from the period, he found the frequency, extra work, but correct answer, 10.5. So he got a 2 mark. Okay, here, correct equation, correct substitution, and final answer 3 SF. So he got a full mark. Okay, now the final graph. See, for the first out of 3, he got only 1 mark because the pattern is wrong. It's like a straight line. It's not a straight line. It have to be a curve, but it's kind of curve going up and come down, come down. So yeah, the shape of the graph A is not correct. Shape correct, not correct. So 1 mark lost. Okay, the answer mark is not awarded to the shape. The peak of F is within half a small square, but the graph goes down to 0 at 0.7 F. The correct resonance curve always has the positive. Okay, so 2 marks you lost because of what? The shape wrong. Second is the amplitude dropped to 0 at 0.7 F. Okay, at 0.7 F, the amplitude becomes 0. Cannot be one. Okay, if you have any type of oscillation, maybe any type of oscillation, when resonance happens, at a lower frequency, it still will oscillate. It will still oscillate. So the graph should be a little up, must have some amplitude. So you missed up 1 mark here. The shape, you lose 1 mark. The shape, you lose 1 mark. Thank God, the peak happens exactly at F or slightly. You see, they go for half of the smaller scale, they're quite particular. Must be exactly F. Half of the smaller scale or one box out also, you lose mark. Quite particular. So this student only got 1 mark for the first graph A. Okay. Next graph, he got 0. Okay. You never get anything. The mistake is, I think the both point join up here. The curve B should always be below. Yes, below the curve A. But I think he almost get the first mark. He almost get the first mark because all below A, but unfortunately towards the end here, he touched the both line. So because touching, they didn't give mark. 0.7 so no mark are awarded for line B. Below curve A, but the two lines are touched at 0.7 F. Yeah, no mark. Okay, no mark. 2 marks gone. So this candidate only score 5 out of 9. So when you draw a graph, follow the procedure. If they say here to here, you draw, sketch completely. Don't leave a small space even. If the peak happens at the center, even half of the box you shift, you're going to lose mark. Okay. So this is the mark scheme. So how the candidate could have improved the answer. So the graph lines needed to be drawn with a correct overall general shape. Don't forget the shape. The major error of the both graph occurred at the 0.7 F. Both lines reached 0 for this student. For the middle one, medium. Line B should always below the line A. Okay, that's the mistake. Okay. So, and the next one, low. Low one. So the low candidate, poor response. He managed to get the calculation correctly, 2 mark. But when it comes to the equation, he got 6.58. The mistake is the equation is wrong. Half m omega squared, x naught squared is missing. So you're going to lose all the marks because the equation itself is wrong. And finally, the graph is, of course, totally doesn't make sense. So you lose complete all the marks. Okay, a lot of mark for graph. Okay, yes. So how the candidate could have improved their answers? Basically, you need to study more. You need to revise it. Okay, the answer started with the incorrect physics equations. Yes, the amplitude term was missing. Needed a better understanding for the shape resonance graph. Okay, yeah. Okay. Any questions so far? Okay, so students, so that's the idea. Okay. The third one going to be repeated the same way. It's going to be repeated the same way. You can check the solution for high and how it should improve, and the middle how to improve. Suggestion you can read through in the same style of the first two questions. Okay. So yeah, these are the tips about your what do you call the paper 4. Okay. Paper 4 rules is about same as paper 2 rule as you follow last time. Okay. The only difference is the which topic need to given importance. Which topic need to be given importance. Not to say importance. You give importance for all the topic is good, but so check which topics like frequently comes out for your idea, and the glossary of commands with the define. You should know what to write. And the third one is the number of responses. Yeah, you can give extra. One extra is fine, but don't contradict. Okay. The most important one, write first. That's what you learn from here. And the BMCA mark, make sure you follow the 4 rules. Write the equation, write the substitution, write the final answer with the proper significant figure and the unit. Okay, follow this guideline always, and make sure the final answer is 3 significant figure. Okay, and please be careful. Almost all the questions there will be a conversion. Okay, so be alert with conversion. If you have a graph, check the graph, the unit at the side. Is it SI unit or not? Sometimes they put microsecond, so you have to convert it. Sometimes in the vertical, instead of joule, they put kilojoule. Sometimes they put electron volt. Unit conversion. is a main error in physics paper. Never happen for other subjects, I think. For physics, the conversion is really important. Okay. So any questions so far? Okay. So, okay, that's all. Good luck for your, okay, good luck for your exam. Okay, do your revision. I think next week is your revision, your exams ready. Every year happens like that. Okay. So try your best for your trial. Okay, thanks.
Thank you, sir.
Thank you. Okay, bye.